Hey, how's it going, guys? Welcome to TechZoo. Today we're going over the 278 question first bad version. So you're a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your products fails the quality check. Since each version is developed based on the previous version, all the version after a bad version are also bad. Suppose you're n versions and you want to find out the first bad one, which caused all the following ones to be bad. You're given an API pool boolean is bad version, which return whether a version is bad, implements a function to find the first bad version. You should minimize the number of calls to the API. So given n equals to 5, version 4 is the first bad version. So you call version 3, it's still a good version, so it returns false. Version 5 is a bad version. Version 4 is a bad version. So you can see that version 3 is a good version. Version 4 is a bad version. So version 4 is the first bad version. Okay. Yeah, so looks like it's a Facebook question, but other big companies also like this question a lot. So because we have to minimize the number of calls to the API, it's very easy to think about. We can just do the binary search or use the binary search algorithm. So yeah. So for example, 1, 2, 3, 4, 5, there are 5 versions. Suppose this is good, this is good, this is bad, this is bad, and this is bad. So rather than going over each element, we can just search the middle point, which is 3, and if it's bad, means that something like before it or 3 itself is a bad version. So we don't have to consider those 4 and 5. We can just do another search from 1 to 3, and we get the middle point, and it's a good version. So number 2 is good version, but number 3 is a bad version. So number 3 is the first bad version. Yeah. So so basically we just get the middle points and get rid of all those bad versions parts and do binary search of the remaining elements, and whenever we see a bad version, we get rid of that until we find the correct one. So yeah, so binary search is our algorithm in our solution. Yes, so to write a binary search, first we have to have a variable called left, and because we are having version 1 to n, so the left is gonna be 1, and our right is gonna be n. And while left is less than right, okay, our midpoint is, like we said, left plus right divided by 2. The reason why I am using the floor division instead of like just the regular division is because if you do the regular division and suppose you have 4 elements and 1 plus 4 is 5, 5 divided by 2 is 2.5. So that's a little bit, because here we are having like integer numbers. So if you just do the floor division, it will be better because 1 plus 4 is 5. 5 like floor 2 will get 2.5, but it gets a floor number, so it's gonna be 2. So it will still be an integer number, so it's a little bit easier for us to analyze. Okay, so and we check if our midpoint is a bad version or not. So we call the is bad version API. Is bad version, and we passing our mid, and we check whether is bad version is true. So if it's true, so it's a bad version. For example, here 1 to 4, we're checking number 2, and it is it's a good version. So it doesn't make sense. So let me just so if number 2 is a bad version, that means we don't have to look all these numbers, right? And we just have to search 1 and 2. So okay, so we have to get rid of this these numbers. So our new right is gonna be our midpoint. Yeah, so we are for this statement, we're basically getting rid of all these elements. Else, so if our midpoint is not a bad version, is a good version. Okay, so